The impetus was COVID-19. The disease is an obvious problem, and rapid diagnostics is key to dealing with the pandemic. Every disease has an odor. This is because diseases change metabolic processes. Metabolic processes have metabolites. Metabolites have a smell. We have in lab a device referred to as an electronic nose. Despite its reduced capabilities compared to the human nose, it's nevertheless a sensitive device. And this device generates a pattern reflecting every odorant it smells. So we decided to use it to try and see if we can characterize the smell of COVID-19. Everybody in the world who has an electronic nose is trying to use it to detect coronavirus. It's the obvious thing to do. I think there are 4 groups in Israel that are trying to do that. All other groups that I'm aware of are collecting material from the people being tested and bringing it to their electronic nose and testing off-site. We think the right thing to do is to test in the field. And so we had to rapidly adjust this lab-oriented setup to a field setup. So we developed a sampling device, 3D CAD design, and this was primarily the work of Kobe Snitz from our lab, that has a one-way flow valve built into it to protect the people we test, that we wouldn't be infecting them back. We then rapidly obtained safety assurance from the Ministry of Health for the device we designed. That's being 3D printed at the Institute. And we incredibly rapidly forged a collaboration with MADA, Magen David Adom, the Israeli equivalent of the Red Cross, who actually manages the testing site, or what's referred to as the Corona drive-through, where people drive in with their car to be tested. So we actually set up shop right in front of the testing station as part of the testing station. Individuals who come to be tested are first tested by our electronic nose, then tested using the formal test currently applied by MADA, which is using PCR at the end of the day. And now we're conducting what's referred to as the learning process. So we're comparing our results to their results and trying to teach, quote unquote, our nose to smell coronavirus. What are our chances of success? In many ways, this is a shot in the dark, because the right way to do this would have been to first characterize the smell of the disease and then to optimize an electronic nose for that particular smell. But it takes a lot of time. That said, rather than sitting idle, we decided we would try. So once again, we're doing something with very, very small chances of success, but the payback will be so huge if it works. I mean, if we'll be able to do it, we get an answer in 80 seconds. That's what it takes us. It looks like we're obtaining meaningful data. We're actually measuring people and seeing differences between people. So we're gaining information that may open a path to rapid diagnosis.